Greetings folks, and welcome into our final webinar of the crazy year that has been 2021. For those re-watching this webinar, this is a re-recording of the live version as we had a few audio issues, so we've chosen to re-record. Today we're covering off intumescent coatings by type and application for steelwork, and this will be presented by Garth Moran from our sister company, Altex Coatings. Welcome in, Garth.
G'day Rob, how are you?
Good, thanks. Good. Thanks for joining us. Now, just to clarify as well, the focus today is on intumescence for steelwork. We won't be touching on timber. We'll cover that off in a full webinar next year. We realised that the info that we put out on the webinar invite didn't clarify whether it was timber or steel. So definitely a timber intumescent webinar next year. Before we kick off, I'll run through a very quick bio on Garth. Garth is the Australasian Technical Services Manager for Altex Coatings and has worked within the industry for the past 19 years. He manages the daily operations of the Technical Services Department, supervising the team as required on inquiries for all areas of the industry. Garth also provides technical and consultancy advice, particularly site corrosion audits to both internal and external customers, and also acts as the principal contact to various external agencies. Garth is also a Level 2 certified NACE coatings inspector and has recently been appointed to the Fire Protection Association New Zealand Council. So congrats on that, Garth.
Thank you.
We will have time for questions today, or we will be, I should say, we will be reading out the questions that came in on the live version. So we will go through those as well, again, in this re-recording. Righto, we will turn off our webcams now and I'll hand over to you, Garth, to kick things off. All yours.
Thanks, Rob. Right, today we're going to just go through intumescent coatings by type and application. So this is building upon the previous webinar that we did earlier this year. So there'll be some repeats in here, but it'll help to drive home some of the information. Just to give you a bit of an overview of who we are, Altex Coatings was founded here in Tauranga in 1954. We're part of the Resene Group of Companies. We do hold #1 market share position within the industrial coatings market. We are a local New Zealand manufacturer with head office and production site here in Tauranga. We've been within the fireproofing market sector for many years now. We've both got technical service personnel here in Tauranga, as well as area representatives across the country, and have the widest range of fireproofing products available within the New Zealand market. Within those sales as well as tech reps, we've got at least 10 qualified coatings inspectors across the length and breadth of New Zealand. Today we're going to discuss some considerations when choosing a coating system or an intumescent coating. Within those, there are a couple of different types that we can split into. First of all is your intumescent or liquid applied type materials. First of all, you can go with a solvent-based, water-based, or your 2-pack fast-track type of products. Thirdly, we'll cover some of the cementitious materials, which can be split into low, medium, and high density materials. Going through some of the considerations when designing a coating system. First of all, thinking about the environment that you're going into. So the actual corrosivity that your building is in or your project is in. Thinking of 2312 or 3404 classifications, which go from C1 to C5. That will have a bearing upon what types of priming and top coating systems that you use with your fireproofing system. You also have to think about your substrate, whether you're dealing with mild steel, galvanized steel, or even thermal metal sprayed materials. There is some caution needed here because of the particular type of material that it is, being porous. So if that substrate is not treated right, it can give you some issues, but it can be done. So it depends on the substrate that you're dealing with, giving you different properties. Your fireproofing materials are generally limited to carbon steel and those associated with the metallized coatings over the top of, whether it be galv or thermal spraying, but we're predominantly talking about mild steel. All the testing is done on those materials, so it only applies to those materials. You also have to consider where the fireproofing is needed. Is it internal, external? Is it hidden? Is it exposed? Is it rain-washed, non-rain washed? Is it architectural? Is it a bit of plant room where aesthetics don't matter? Is it inside or outside the thermal barrier, so cold or warm side of the insulation? Is your project going to span a season or multiple seasons? Is it 3 months? Is it 6 months? Is it a 2-year contract? What's the environment that your particular project or building is going to be in during as well as after construction? So thinking about a particular chunk of steel might be destined for interior enclosed, but for the length of duration or for the vast majority of it, it may be exterior exposed, which can have a big impact upon your choice of intumescent and or system that you throw at it. Also thinking your life to first major maintenance of your total system can go from short right through to extra long term. That will have a bearing upon the priming systems that you choose and the top coating systems that you use to protect your intumescent or your fireproofing systems. With all except epoxy intumescents, your intumescent coating is not part of, or not a recognized part of your corrosion protection system. It stands adjacent to it, neither contributes nor encourages any sort of corrosion to any proven degree. There are materials out there like the epoxies that do contribute towards it, so you can't include those within your calculations for corrosivity protection. Moving forward into your intumescent coating materials. So these are actual liquid applied materials that offer superior fire protection for your commercial and light industrial projects. Can provide your high-end architectural finishes and gives you options to develop specs to meet all building types, the project requirements, and the different conditions that you get within those projects. First of all, we'd like to cover off single pack solvent-based materials within our range. That's our FX 2003. This is a product that offers the convenience of single pack application with a moderate level of weatherability. It is designed for both shop and site application. It can achieve up to 2 hours worth of fire protection, but typically tailored towards the 30 and 60-minute mark. Moving towards the comment that I made about the weatherability, this particular material, even though it's a solvent-borne material, has been used for many, many years. We have noted over the years, especially an increase towards where you got higher fire ratings and therefore higher film builds of the material and longer terms of exposure to the environment. You will find that these types of single pack materials do have a limit with regards to the amount of moisture that they can hold and put up with regards to ponding, pooling, or even high humidity, constant high humidity. For want of a very simple explanation, moisture can dive into the film, dissolve out the raw materials that give the chemistry its properties to puff up and protect the structural steel. It can then deposit that back out onto the outer surface of the intumescent and or even be washed away in the next rainfall. In order to stop that, we developed a product called ProSeal Intumescent Seal Coat. For want of a very basic description, this acts like a one-way valve, keeping water out, but still allowing the solvents to transmit through that particular seal coat to complete the curing process and to ensure that the intumescent coating is completely solvent-free. So A, gives you very, very good water protection for that material, enables the protection of that maybe interior enclosed structural steel during the construction period where it is exposed to moisture. Your atypical conditions within New Zealand, especially over winter, you'll get rainfalls, and yes, you'll get dry periods, but that moisture will hang around in areas of collection, or even if it's not designed for collection, you'll still get drip lines underneath bottom edges of flanges, or even within stiffener plates within the structural steel will get water trapped there. And after several days of non-protected intumescent, it can start damaging that intumescent film. With the ProSeal in there, it minimizes that risk to almost zero. You've got very little chance of that being affected by any sort of environmental conditions that you can throw at it during the life. Moving towards the next category of water-based single packs. So within our range, that's the Nullifire SC802. Just like the FX2003, it offers the convenience of single pack materials, but it is even more so moisture sensitive compared with the FX2003. So from the point of application onwards, you need to have this material applied within a watertight space, effectively a well encapsulated building, not going to get environmental moisture or rainfall coming through onto it and damaging material. Provides you the option for very low VOC intumescent coating. It also allows you to work within green building requirements as well with those low VOC requirements. You can still achieve a high-end architectural finish if you want to put top coats over the top of it, and can be twinned in with your normal decorative systems that may be used on, say, jib board, for example, right next to your structural steel. So it can be used as an architectural type feature. As I mentioned, it's really only designed for interior use, much like what we have designed the FX2003 for that material. Even though it's solvent borne, we put a restriction on it that it shall not be used for full exterior exposure. You could use that FX2003 in an outside of the thermal barrier, but still clad in and protected from direct rainfall and UV, but that would include a compulsory step of the ProSeal intumescent seal coat. That same seal coat can be used on top of the SC802 if there's some sort of perceived danger of moisture forming within the area that that particular product is used. But again, it's designed for being put into essentially a watertight area of the building site where your fire-rated steel is present. Moving on to a big step up with regards to weatherability is our Fast Track 2-pack product called Nullifire SC902. This is a product that's optimized for both on-site and in-shop application. Again, like all the others, it can achieve up to 120-minute fire ratings, but the big important key here is its speed of cure, as well as its ability to achieve the large film builds that you can get at 120-minute ratings. So, for example, the SC902 can be applied at, let's say, 5,000 microns, so 5 millimeters thick in one application, or you can split it up into 2 or 3 applications to get a more smoother architectural finish. To get the same kind of film build out of the single pack solvent-borne FX2003, of which there is a limitation of about approximately 800 microns dry film thickness per day in ideal conditions, 20 degrees C, 50% RH, you're looking at 8, 9, 10 coats to achieve the same sort of film build. So a huge difference, absolutely huge difference in the speed of turnaround, the amount of application time, and the interruptions of other trades on the building site as well. So it's a product that's ideally suited towards fast tracking your fireproofing requirements on site, speeding up your overall project timelines. Project timelines equals money. Simple as that. Even though your cost of material might be slightly higher than your single pack materials, you win hands down on the amount of time that you save on a project. Minimize the actual downtime, you maximize your amount of work that you're doing per spray day as well. SC902 can be applied direct to metal and C1 type of environment, so you can offer significant cost savings there. And you can, again, make that into a visible feature, or whether it be clad in behind jib board, for example. It can offer you another string to your bow there of selections. You can reduce your overall project life, your project timelines by approximately 60% compared with your single pack alternatives. So a very good product to have within the stable for you to choose from. Moving on to cementitious materials. Technically speaking, these should be called spray fire resistive materials, or SFRMs. These materials can be split up into what's called vermiculite materials and or Portland cement materials. The vermiculite materials are a softer material and much more water sensitive materials, whereas the Portland cement, again, like concrete, offers you significant strength as well as weatherability difference compared with vermiculite. Offers you a range of choices from both concealed as well as fully exterior exposed structural steelwork that requires fireproofing. There's cementitious types, which I'll just use as a common acronym there to describe all these materials. They can give you a durable material. They're applied in a wet mix. What I like to describe is sprayed on wheat bix, which is kind of seen in the photograph that you've got in front of you here, which is very akin to our Southwest Type 5 GP material. You've also got the Portland cement based products within our range, which is called Pyrocrete 40. These have been designed and formulated to meet any of the design specifications with regards to density, the performance requirements and criteria that you may want from them, and international building codes, which includes the New Zealand Building Code as well, giving you some really good flexibility within your design and construction methodology as well. Your Portland cement type materials can be divided up into low, medium, and high density, and you can in fact get those variations within your vermiculite materials as well. The density types are based upon the different bond strengths required and are dependent upon the loading upon which you place those materials. So if you look at the image on your right hand side there, you'll see a different split in between the different types of fire rating materials depending on where in the building that they are, what kind of bond strength is required, how much physical load has been put on them with regards to deflection and strength and loadings that you have within your structural steel. So you can mix and match where you want these materials to where they're best suited and to give you the most cost-effective solution. There's some really good podcasts available through our technology partner Carveline within the USA, where you can learn some very effective yet simply described differences between the gypsum and Portland cement types. We'll put a link on our LinkedIn profile after this, which you're more than welcome to listen to and to watch. These are only small 10 to 20 minute little bites of information, really easy to digest and understand, so really worthwhile having a look at there. So cast a look into our LinkedIn profile and pick those up from there. Moving into a kind of overall summary of single versus two-pack products. I've pinched this particular table from the FPAN's Code of Practice, which you can download from the FPAN's website, or if their website is still down due to reconstruction, we will also be able to send this document through to you if you give us an email or chat up through LinkedIn. We'll be able to send that out through to you. This particular table gives you an overall view of all the different fireproofing types, interior versus exterior, and the different corrosivities that you get within those possible environments. So as you can see from the table, as the higher the level of corrosivity, the less and less products that you have to choose from, but you do have a choice in there. Your interior has a lot more choice. You can mix and match there depending on your requirements to best suit your project at hand. Moving into a summary of all this information, there's quite a few considerations for choosing a fireproofing coating system. You have your fire rating time, so whether you have a 30-minute rating versus 120-minute rating can have a direct influence on what type of fire rating product that you choose. The surface preparation required, the cementitious materials require a lot less compared with what you get out of the liquid applied materials, so that can offer some significant savings. System compatibility, so you got to make and choose the right products, both priming and undercoating, as well as top coating to protect your intumescent coatings. Whether or not you require an aesthetic finish, for example, you're sprayed on Southwest Type 5 vermiculite material, looks more like sprayed on wheat bix, but that may not matter, for example, being used in an underground car park. Where you do want an architectural finish, something more along the lines of your liquid applied intumescent coating might be more beneficial for you there. The different types of environmental exposures, internal versus external, during commission use versus construction. What kind of environments will it see during that construction phase? The ease of application, are you geared up for single pack or are you comfortable with 2-pack? Are you wanting to minimize the amount of site time that you want on there for the maximum value of dry film thickness being put on there? The type of intumescent being used, for example, whether you're restricted to Green Star options, which you can then more than likely go for a waterborne if you are looking for a fully enclosed watertight building, or you do have the option of the SC902 material, which offers also a Green Star certification, albeit on a slightly different rating scale compared with single packs, which is allowed for under Green Star buildings. You've also got the choice of splitting your project up into single pack, 2-pack, which includes the hybrids as well as the epoxies. You've also got the cementitious materials, which can offer you significant cost savings compared with the liquid materials. And each, again, you've got specific products for specific environments to which they're best suited. That rounds up the presentation part of today. Hopefully that gives you a very broad overview and good idea of what you can do, how you combine different products to different situations to get the best out of your project at the time of design. I'll hand it back to you now, Rob.
Thanks very much, Garth. That's very interesting. We'll flick our webcams back on. And there we are, excellent. So as mentioned at the top, we do have some good questions that came in during the live version of this recording or webinar. So we'll roll through those. There's some really quite good questions that came in. First one is, are there film build restrictions to primers and undercoats for the cementitious products like there are for intumescent products?
Great question, great question. Yes, there are some differences there. Just for people that may not know, there is a limitation for the film build that's allowable underneath your liquid applied intumescence. Within our product range, that's 150 microns. That is because of the particular testing within the fire furnaces that's done has that limitation. Your cementitious type materials or vermiculite are not restricted to the same kind of limitations because of the different way that bond strengths are evaluated and how the actual products protect the intumescent as well. So you can have the option of going higher to 200, 300 odd microns to give you added barrier protection for corrosion resistance underneath your fireproofing system. So that's a definite opportunity there.
Actually, I'll just throw in a question myself on the cementitious products. Is every now and then we get a query on painting them out. You know, they've been in situ, been in place for a while. Someone takes over a tenancy, don't like the look of them. They're an exposed ceiling area, and they want to paint them out. What's the normal advice for that?
Okay. Yep, we've had that a couple of times as well. For your vermiculite materials, which, as I said before, it's much like sprayed on wheat bix, has that kind of consistency as well. You can poke your finger through it with only a little bit of effort, so it can be quite friable. But you can apply on top of those just with your normal acrylics. You just have to watch the sealing phase first, so a thin down coat of those materials before you chuck on your major film build to get your colour and your looks on there. The likes of your Portland cement-based materials, so Pyrecrete 40 type materials, you treat them exactly the same as concrete. So you put down a sealer coat and then whatever the top coat you want over the top of that. Again, you've got a bit more choice there. You can go with your acrylics, appropriately primed, of course. You do have the option of going on top of that with your more durable two-pack materials, so your epoxies and urethanes, to give them a bit more oomph, particularly so if they're exterior as well, gives you just a little bit more protection there on those types of systems.
Cool, excellent. Another one that's come in: if you have water damage to your intumescent coating during construction, how do you know that it hasn't suffered damage to its fireproofing ability? And as we've talked about with this one, this is really relevant due to the most significant construction or fire damage building that we have in New Zealand at the moment, being the NZICC Convention Centre. So that would be interesting for you to talk through that.
Absolutely, yeah. So if you do get water damage onto your intumescent film system, particularly that one that has been sealed or top coated, you may not know, you may not be able to visually see that it's been damaged. So for example, the NZICC building where the fire was located, that was up on level 5, the actual area of damage that you got directly from the fire itself and the heat was relatively confined. You probably would have been in the first 20-30 metre radius of that particular burn zone. That's where the damage on the structural steel really occurred. The big and widespread damage was the millions of litres of water that got pumped into that building for firefighting purposes. So particularly so in the basement areas where it all collected. That was there for weeks and months actually, where it just sat. There was probably a good metre and a half of water sitting in that bottom basement where it was just sitting idly. There was no ventilation, no draining available at the time, just because they couldn't get back into it. There was just huge amounts of water damage in there, and particularly in the lower basement levels. So not only directly from the water contact, pooling itself, but also the rampant humidity that you had in there. It was like being in a steamy jungle. Even after they drained the water in there, very little to no ventilation in there. Just the sheer amount of humidity in there was quite high. Going back to the original question, yes, you can test for this. There's some pretty simple analytical techniques that you can use that we have access to here at Altex in Tauranga in our fire labs. It's as simple as taking a small sample of your fireproofing material, probably even as low as a 1 inch square is enough to give us an idea. Back down to the undercoat, we can take that particular sample and run it through FTIR, which is an infrared spectroscopy analytical technique. It gives a chemical fingerprint of any coating material or any material for that matter that you can compare against the standard material that's in good nick, and that you can compare, is it still the same, does it have the same materials that give rise to its intumescent qualities. The other way that we can do it is a little bit more qualitative instead of quantitative, is simply putting in a furnace and burning it. We will have a decent idea of how much expansion that you get from the fired up film, and we can compare that against the known standard to say, yes, it's okay, it's still alive, or it's compromised or even dead. So it can be done. It's relatively simple. We've done simple one-offs for different projects, just because they wanted to know if it starts ramping up in the quantities, we have a little charge to it, but it's no great effort there, and it's not going to break the bank. And for the security of knowing what you have left on your building with regards to fireproofing, that gives you a known quantity there that you can deal with.
Excellent. Yeah, there were a few questions come in around moisture, and a couple around where fire sprinklers have gone off as well. So I guess that's a given that any sign of moisture is likely to be issues with intumescent coatings.
Absolutely, yeah, and certainly post-fire or post-firefighting measures even, the intumescent coating has done its job. If it's been applied correctly, it's done its job. From that point onwards, you should reevaluate it. Yes, it saved the asset, but you may have to strip it off and take it off back down to sound undercoats and restart again. Areas which may not have been exposed to direct moisture and or water contact, you may get away with things there, but any areas where sprinklers have gone off, firefighting water has been involved, where the water's tracked for drainage, all those areas need to be reevaluated. You can't just assume that, yeah, it looks good and it still must be in good nick. It doesn't apply, so you've got to test for it.
Yeah. Another very good question, and you touched on this earlier in your presentations, I think. Are there efficiency gains in splitting up a project into several types of the various types of intumescent or cementitious materials?
Absolutely is, definitely, yeah. So we know of several very smart contractors that have approached it in this type of way when they've been quoting for jobs. They'll split a project up into different environmental categories with regards to location of the fire-rated steelwork on a particular job. So, for example, anything exterior exposed will go for our SC902 product, which is the most suitable for that type of exterior environment. Anything that's within the perimeter zone, it's going to get hit by water and rain constantly during the construction phase. Again, you'd be using the more durable products, SC902, or even the Pyrocrete 40 being the cementitious type of material. Anything that's a bit more protected from it, that's where you can choose to use the likes of your waterbornes if it's fully encapsulated from any sort of moisture contact. But if you're more open, that's when your FX and your ProSeal comes into play. Anything that's put into the building that's been made watertight, or there's no chance of water being got onto it, or, for example, underground car parks is an absolute sitter for the Southwest Type 5 type material, vermiculite material. The cost savings of those, the different splits, particularly using those cementitious materials, is huge. The cost difference between those materials versus your liquid applied materials is rather large if you've got, especially so larger buildings, and they can offer some pretty significant savings. You also get the effect of, given the current status of shipping times and raw material shortages to make some of these products, putting all your eggs in one particular Intumescent Coatings basket or product basket may not be the smartest idea at the moment. If you spread your load with regards to different products over different areas, then you lessen your chances of any impacts with regards to shipping interruptions or timings within those. So yeah, a bit of a double win-win there. So monetary as well as timing during the actual coating phase itself.
Yeah, and I'll just jump in and add as well that it's a really quite a specialist area to know what you're doing when you're specifying intumescent coatings. Particularly, it's hard enough on our side of the industry to understand it all. I can't stress enough for those watching to always include your preferred supplier. Yes, technical team, specifier team for assistance in putting your specifications together to get the best outcome and cost-effective solution, I guess. It's a tricky thing. I know navigating through the likes of master spec, putting a specification together, particularly in the intumescent areas, quite challenging, as I mentioned before, even when you're on this side of the industry. So definitely do include your preferred suppliers' technical expertise in your specification writing.
Absolutely, and get us on board real soon within the design phase when we can affect the best advice upon the solutions for your building as well. We've done it before for many other architectural firms and engineers where they've given us plans that we've got these particular situations, we're thinking of using this particular cladding or attaching something. What's the best way to design around this? How do you achieve these kind of designs but still be kosher within the fire space as well? So definitely.
Now, this question came, there was a few around this topic, and it's timber framing. When you're attaching timber framing to intumescent or cementitious fireproof steel, that's quite a common question that comes in nowadays.
Yep.
What are the do's and don'ts?
Righto. So we investigated quite a few of these options. There's two answers to this particular one, spread between the intumescent coatings and the cementitious types. I'll answer the intumescent one first, because that's the most common. We started off and have continued to do so, and continuing to do so, more testing now through our partners at Nullifier in the UK, utilising their fire testing labs, where we've literally constructed a steel item, cut it up in the SC902 type material, and wrap different strapping of timber around it, whether it be around a strap ring kind of formation around a steel column, or even longitudinally around the same type of column. So different surface areas involved, different structures that you'd be using to attach your various cladding, jib, etc. to, and see the effect of how it performs in a fire. Does it actually affect the overall performance of that structural member? In a nutshell, across the board, generally speaking, so you can, up to 60 minutes especially. There is provision to possibly go up to 90 minutes, all depending on the configuration that you have within your structural steel. So that's, as you alluded to before, that early involvement of the likes of ourselves in the tech department here at Altex and Resene. We can give you that advice. Shoot us through those plans and explain what your issue is, so that we can give you some really good guidance around that to solve that methodology problem, but still, again, be kosher with what is required with regards to fireproofing. The second part of it, for the cementitious type materials, that's affected by what type that you choose. Your vermiculites, as I said before, it's sprayed on wheat bix, so it's quite light, friable type material, so it doesn't like really being fixed to a whole heck of a lot. It's fairly easily damaged, so that's probably not the most best to. If you do choose to fix to it, you more than likely have to effect a repair, which isn't too hard. It's totally doable. Your Pyrocritic 40 materials, being Portland cement, a lot stronger, so you can actually fix direct to it. Pre-drilling holes, etc., so you minimise the amount of cracking damage that you do when you're fixing through it. Those materials, you don't need any expansion gap or have to worry about expanding, because those cementitious or materials don't work by expansion. They work by sublimation. For want of very basic description, they use the water that's inherently in those materials to cool down the steel as it's heating up, so sacrificing it that way. There is no expansion, so you can affix directly to those materials. Using that analogy back onto the liquid applied intumescence, the area underneath your timber attachments is effectively cancelled. It doesn't puff up, it doesn't provide that, but the thickness of and the char factor that you get from your timber, namely a bit of 4x2, so 45 by 90s, so you have to have 45mm minimum on there. That's enough to provide the heat protection to those areas that it covers. The rest of the steel that isn't covered by the timber framing is protected by the intumescent itself, so they work in tandem and they will give you those fire ratings. But if you want the specifics, more than happy to help out, or send you the little technical bulletins that we've got put together for those particular sets of testing. And as I said before, we've got some more testing on the go currently in the UK, so we'll be coming up with some more technical bulletins on that. So
cool. Now you touched on damage as well, so that's a common question that's come in here around intumescent coatings that are quite simply damaged during construction, and it's a really common thing. So how is this rectified, and is it feasible to overcoat, or is this precluded because of the overall intumescent thickness for the coating being exceeded? Now that's two questions in there, I think. So around site touch-ups, and then film build, exceeding film build, I guess.
Yeah. So easily doable for both liquid applied and cementitious type materials for spot repair. Unlike your initial shop application where your surface preparation has to be abrasive blasting, more than likely, for your liquid applied intumescence, on site for repair, site damage, transportation, erection damage, all those materials can be repaired by power tool cleaning. A couple of different standards, the SP3 and SP11 are typical, depending on the level of corrosivity that you're facing. Reinstate the priming system, or a priming system that's appropriate for the environment, zinc or an epoxy type materials usually. Reinstate the intumescent coating within that area, lapping up the area of damage which has been feathered in, and then re-top coating over the top of that. particular material. So yeah, that's easily done. For your cementitious types, it's even more simple. You're just scraping away the affected flaky or damaged material and just hand applying that cementitious or vermiculite material back into those spots again. You can physically hand pack it, or even hawking board trowel, knifing it in. All those methods are doable again, as long as you achieve the film build that's required for both sets of products. That's still kosher, so relatively easy. Usually, again, done towards the end of the project or the areas where it's pretty much low chance of being damaged again. The contractor will come back through and effect all those repairs. The second part of the query there with regards to exceeding film build. Yes, there is a limitation to your maximum film build for your intumescent coatings. That is for the maximum tested value for a particular structural member. So for a hollow section or a UB or UC type section, they each have their maximum applied film build. That's usually you find from the 120-minute loading tables. So you're effectively looking at film builds that are in excess of 6,000 to 7,000 microns, so 6 to 7 millimeters. So if you've got your fire rating that is only sitting at a 30-minute rating, you're only staring down the barrel at 200 to 400 odd microns. There's no way that you're going to even get close to 6,000 to 7,000 microns unless you like wasting paint. You really only have to watch it if you've got 120-minute ratings in which your limitations are very close to those maximums. So within our coatings, you've got a maximum of your maximum tested plus a 10% slot factor over the top of that, just to allow for a little bit of practical overbuild in there, which is inevitable anyway, but it's still within kosher limits with regards to the testing. So yes, it is not so much a worry, really only to do with the 120 minutes that you need to be cautious of.
Mm-hmm. I just want to add something there as well, as you talk about film builds, and sorry, I'll start again on that. It's very critical for the contractors applying intumescents to be skilled, trained, and understand what they're doing. Unfortunately, all too often we have contractors who don't have a lot of experience in intumescent coatings, and it's very easy, should I say, to get it wrong very quickly with intumescent coatings around wet film thickness, equating to dry film thickness, and loading schedules, and then that's an initial application, and then site touch-ups by maybe not the contractor that applied the intumescent to begin with. So we often get inquiries about, oh, can I grab some of that SC 902 because we've got some site touch-ups. And our question back would be, well, do you understand what's the loading schedule? Do you understand what your film builds are? And so my point is, I'm just trying to stress that it's really important to know that your contractors that are working on intumescents are experienced in this area, because they're a critical component, or the critical component to a building.
Absolutely, yeah. A lot of people think it's just another coat of paint, another pot of paint on there, but it's not. Its primary driver is to save lives. That's what the product is there to do, and to give you the time to get out of the building while it's on fire, give the fire department some time to get there and try and save the asset, but first and foremost to save lives. So we set up within FPAN's code of practice revolving around those types of levels of professionalism, the applicators, right from the blast and prime guys right through, but more importantly so the intumescent applicators, to have that level of training, the professionalism, level of QA and QC within their systems to show and prove that they have put on what they've been employed to do. And if things happen to go wrong, they've got the records to go back on and check those and rectify if required. And I can definitely vouch for that back checking exercise post NZICC. There was a lot of questions raised, and the guys that were involved in there were able to prove that yes, they'd been able to put it on, and we were able to prove that yes, our product did its job, which is obviously paramount. So we've been setting up those structure within the FPAN's code of practice, giving those qualifications, you want those guys that are more professional. Yes, they may cost a bit more, but they're going to make your project run that much more smoothly. Your reviews by your reviewing engineers doing your PS4s, that process will go that much more smoothly, and you'll get a much more easy transition to get your final consent at the end of the day. If you use your fly-by-nighter cowboy painter, good luck to you. You may or may not get what you paid for, and your quality may or may not be there. Who knows? So that's what we've been trying to strive for and achieve a higher level within the industry to pick up our collective socks, if you will.
I'll just add in there as well to anyone watching this is beware the very low quote or price on an intumescent contract. Yeah. Because often there's not enough product, not enough intumescent coating allowed for in the price. So I won't bang on about that, but yeah, skilled and experienced applicators is where it's at for intumescent coatings. Now, I'll ask one more question because we've been travelling along quite nicely. Are you seeing any new solutions in the area of intumescent coatings on steel? Now, I could probably split this into two, I guess, around just the coatings and also other materials that are coming in to the industry as well that have steel fixed hard up against it, should I say?
Yep. There's most certainly always new technologies coming through, better raw materials selection that can be used to improve the weatherability of some of these single pack materials, which we are currently looking into as well through our partners overseas. There's certainly the more novel type like the SE902 that is a very unique product that's out there. We do have the epoxy intumescents within our range as well. They offer different properties and advantages compared with other products. They are a little bit more specialist, requiring a bit more specialist application gear, but they can offer some advantages there. Certainly with regards to the different types of construction, so what the likes of speed wall and co-rock type systems are joined to fire rated steelwork. Yes, that has been looked at. I've been in conversations and I've been part of some of the testing through with the guys from co-rock with using some of our products and running some tests, some fire tests, furnace tests in conjunction with their systems, which good positive results. And by using that, we've been able to offer architects and engineers some good solid advice on their design methodology in order to get past muster with regards to building consent as well. So different ways of attaching your co-rock to your structural steel without compromising your fire rating as well. So the more that we get involved and the more testing that we do, the more light we can shine upon some of these construction methodologies and advice that we can give, more solid advice that we can give to the likes of architects designing buildings with a decent amount of surety.
Very good. Well, that brings us to an end. Thanks, Garth. That's all been very, very interesting. If anyone does have any queries, please do contact the technical team at Altex. You've got a great bunch of and highly experienced and skilled team there on the end of phones and emails waiting for calls. So I can't recommend that enough. If there's anyone with any queries on protective coatings or intumescent coatings, to contact Altex direct. And also, of course, the team at Resene can help out as well. Also, please do be sure to jump onto the Resene website and watch any of our previous webinars. They're all sitting there and available for you to watch and also earn your CBD points on rewatching those as well. But as I say, that's us done for today. Thanks for tuning in, and we will see you all at the next Resene webinar. Bye for now.
Thanks, everyone.